sorry, we're in 11. We're going to talk about common logarithms and base E and natural logarithms today. If you're ever given a logarithmic problem and it doesn't have a base number written, that's because it is a base 10. The 10 is invisible. So if you look at a calculator and you see a log button, that log is a base 10 log only. I showed you how to put in other logs into the calculator, and I'm sure I'll show you again later. For number 1, we're going to solve 4 to the x power equals 19 using common logs. So we're going to apply the common log to both sides. So that means log base 10 of 4x is equal to log base 10 of 19. Again, the 10 is understood to be there, so you don't have to write it. To get x from being a power, I would have to apply the logarithmic property that allows it to move out in front. So that means x times log base 10 of 4 is equal to log base 10 of 19. Now if I want to get x by itself, I would divide both sides by log base 10 of 4. And then x is alone on the left-hand side. And it equals log base 10 of 19 over log base 10 of 4. Now we grab the calculator and put that into. So alpha y equals 1 for the fraction. And again, this log button is a log base 10. So log, you don't have to type it. The 10 is already there. And then log base 10 of 4. So x is approximately 2.12. Number 2, express in terms of common logarithms. So we're going to use the change of base formula, which is up here. So the change of base formula can be used for any base number, as long as the base number is the same, but we're going to use common log. So we would say that log base 10 of 20 over log base 10 of 3 is the same thing. So all they wanted us to do was express it in, so they don't actually want us to calculate it. So I'm done. I want you to answer number 3. For number 4, I need to use a log on both sides. So let's go ahead and use the common log on both sides. So I would now have log base 10 of 2 to the 7x minus 2 power is less than or equal to log base 10 of 20. Again, I use properties of logarithms to bring that power down in front so that I can get to x a little more successfully. So that means it'd be 7x minus 2 times, sorry, my pen decided to not cooperate, times log base 2 is less than or equal to log base 20. Now I would divide both sides by log base 10 of 2, so that I'm left with 7x minus 2 less than or equal to log base 10 of 20 divided by log base 10 of 2. I'm actually going to calculate this so I can continue on because it's going to get really messy here. So alpha y equals 1. So log base 10 of 20 divided by log base 10 of 2. It's about 4.3219. So 7x minus 2 is less than or equal to 4.3219. We want a lot of decimals, and when it says 10 thousandths, that means 4 places behind the decimal. So now I would add 2 to both sides, so that's 7x less than or equal to 6.3219. And then divide that by 7 to get x alone. So x is less than or equal to, so plus 2 divided by 7. About 0.9031. Now, I made a mistake on our last video about the inequalities, so I want to correct it. When it comes to the less than inequality in particular, not only do you get this as an answer, there's an extra step we need to take. So the extra step is to take the term 7x minus 2 and check to make sure it's greater than 0. So let's do that. So 7x minus 2, we're going to check that it's greater than or equal to 0. So that means add 2 to both sides. So I would have 7x greater than or equal to 2, and then divide by 7. So x is greater than or equal to 2 over 7. So I know that looks crazy, but the correct answer to this question would be 2 over 7 less than or equal to x less than or equal to 0.9031. And let me make sure 2 over 7 is less than that. Yeah, just to be sure. So always got to check that, okay? Where did my stylus go? Sorry, guys. It's not cooperating. I can't see it. Now we're going to talk about base E and natural logarithms. So E is a number that's approximately 2.718, and it continually goes on, kind of like pi. It's a pretty common exponential function. So it works just like any other exponential function, where E is the base. And then we have what we call the natural logarithm, which has the abbreviation ln. And it is the inverse of the E exponential function. So just as we could change other logarithms and exponential forms from one way to the other, we're about to practice doing the same thing with E and natural log. So E is my base, X is my power, and 8 is my number or my answer. So to put it in logarithmic form, it would be natural log answer is equal to power. And when you write ln, the e is invisible, so you don't have to write it. You can write it to be on the safe side, but it's understood to be there. So in a similar manner, there's a little bit of e right here. Start at my base, go to my power. So e to the power of 2, and then is equal to x. And that's how I would convert this one. So we've practiced this before. This is just another base to be familiar with. The same properties of logarithms work for natural logarithms also. So this example wants us to express it as a single log when I have 3. So first I will start with any coefficients I might see, and I see a coefficient here. It needs to go back as a power. There's a coefficient here that also needs to go back as a power. So that means it'd be 3 squared and x to the 5th. Bring down the natural log. All right, and now we can combine 2 at a time. So I see that 10, the natural log of 10 and the natural log of 3 squared are adding to one another. So that means I can multiply those. So 10 times 3 squared, which is 10 times 9, which is 90. So the argument of my natural log is going to be 90. And that means I can combine those two to 1. And now I have 2 natural logarithms with subtraction in between. So I take the 2 arguments and I divide them, putting 90 on top. And then I can write only one natural log. So that's it. So again, the properties can go backwards or forwards. It doesn't matter. Sometimes you want to take several logs and make them become one. Other times you want to take one log and expand it into several. I want you to try solving this one on your own, and let's see how you do. Just solve the same way you solve any other exponential equation. If you can't get the same base, then you use logarithms on both sides. All right, we're also going to have inequalities. Solve the same way. So since this is a logarithm, I need to use exponential form on both sides. So I'm going to use a base e exponent. So that means the natural log and base e cancel out, bringing the argument downwards. Uh-oh, sorry, rewind. Undo, not yet. The first thing I want to do is take this power and move it out in front. So that's 4 times the natural log of x minus 8 is less than 4. I then will divide both sides by 4 to get this to cancel. So that leaves me with natural log of x minus 8 is less than 1. I now will apply a base e to both sides, so that the natural log will disappear here, leaving me with x minus 8 is less than e to the power of 1, or just e. And then I would add 8 to both sides, so that means x, sorry y'all, my pen is tripping, is less than e plus 8. So x is less than, and we grab our calculator. So E is located when you hit second natural log. It has a power of 1. Get out of the power, and then we said plus 8. So that's about 10.7183. 10.7183. 7183. And again, with the less than, we have to do the other part of the problem. So we take our argument. Our original argument was x minus 8 to the 4th power, and check to see that it is greater than 0. So I would first get rid of my 4th power by using the 4th root on both sides. So that means I would have x minus 8 is greater than 0. And then add 8 to both sides, so x is greater than 8. So the solution to this is 8 is less than x is less than 10.7183. And last but not least, we're going to talk about continuously compounded interest. Here's the formula in exponential form. A equals P times E to the power of RT. Or in logarithmic form, it has its alternative as well. When Lily was born, her grandparents deposited $3,000 into a college savings account paying 4% interest compounded continuously. So let's break it down. $3,000, that's P, our initial of that. 4% is our rate, but as a decimal, that's 0.04. The first question says, how much will there be after 10 years? So that means that's T, 10. So the amount is equal to P, which is 3,000, times E to the power of 0.04 times T. And then we put it in the calculator exactly like that. So 3,000 times E to the power of 0.04 times 10. Double check to make sure everything's entered correctly before you hit enter. So it's about 4,475 and 47 cents, because we're dealing with dollars and cents. And how many cents again? 47. The next question says, how long will it take for the balance to reach at least 10,000? So we know we want A to be 10,000. We know we started with 3,000. We know our rate, 0.04. We don't know T. So the first thing I would do is divide both sides by 3,000. So 10,000 divided by 3,000. It's about 3.333, which is equal to E to the power of 0.04 T. Now I would apply a natural log to both sides. So I would have natural log of 3.3333 is equal to 0.04 T. and then divide both sides by 0.04 to get t by itself. So I would put natural log of 3.33333 divided by 0.04 into the calculator, and that'll give me the approximate time. So alpha y equals 1. So the natural log of my previous answer, I'm just going to hit second answer, so that way I don't have to type it, divided by 0.04. So that's about 30.1 years. Wow, it's a long time. All right, this concludes your lesson for today.